Hey, Professor. We're coming back at you with problem 8.3.6, which talks about the root test. Um, so, in part A, we're asked to assume that the nth root of a sub n approaches r, and why does this tell us that a sub n is approximately r to the nth? Well, um, the reason that it tells us this is um, when we turn nth root of a sub n to a sub n to the 1 over nth power, um, if we have any exponents used in a sub n that was is n basically. So if you have any exponents in a given function that are n, when you have that 1 over n outside of everything, not incorporated into it yet, then it'll get rid of that a sub n, or that nth power inside, and then also cancel out the 1 over n on the outside. So then whenever that happens, we're basically left with just the function a sub n, and then you can look at it as a geometric series, and you can take it out and kind of pick it apart. Like if you given 3x squared minus 5n, and then you have 15x squared plus 10. If you look at it, then those x squared powers are the main components, and then you can just break it into a constant where it's just 3 over 15 as that constant, and then that will be r to the nth. And so then it turns out that this can also look like a geometric series, which is what we'll talk about later. Uh, so um, in part B, we're asked to look why a sub k, or a sub n, pretty much, um, looks like a geometric series. And so it looks like a geometric series when you take nth power of the absolute value of a sub n, and you turn it into the absolute value of a sub n to the 1 over n. That's basically a geometric series right there, because you have function raised to the power of something, and then that's basically fulfills the what a geometric series is, a constant raised to a power, which is kind of which is exactly what that is, pretty much. And uh, we're then asked to compare it to, like, if we're doing a comparison test, what we can compare this a sub n function up here to, and I'm pretty sure we can compare it to a sub k plus 1 over a sub k. So it's just looking at that constant value once you figure out what everything inside is, and once everything cancels out, you should just be able to look at that constant, a sub k plus 1 over a sub k, and then you should be able to compare it and then see if it's convergent, divergent, or whatnot. And then in part C, we're asked to find what values of r or n will make a sub n, or the summation of a sub k, converge. And it'll be the same as the ratio test, since the root test is similar to the ratio test, and the geometric test, or a geometric series, and what makes that converge is basically if r is greater than or equal to 1. And I say equal to 1 because if you get 1 in a ratio test or a root test, then it could either be absolutely convergent, conditionally convergent, or divergent. So you'd have to do another test in order to find out. But yeah, so it's like the p-series test as well. If n is greater than 1, then it converges. So yeah, as a reflection, Uh, I bet I could have done my handwriting a little bit better, done my notations so that you might be able to see it. Um, and then also, I don't think I should be on the floor. Uh, I feel like that kind of doesn't help with you seeing my uncle's stuff over there. So I might try to have change that, find a different background. Maybe put it over here where you see my Lego collection. Something along the lines of that. But yeah, I think that's it for this problem. So thanks and have a great day.